So in today's video, we want to talk about heat moving through the atmosphere and the greenhouse effect is what we're going to be looking at today. Now, in our last lesson, we talked about the heat budget and how heat arrives from the sun or in the form of incoming solar radiation or shortwave radiation and then is re-emitted by the Earth as long-wave or thermal radiation. So let's start by looking now at the different ways that heat moves through the atmosphere. We're going to start off with the first one, and that's convection, conduction, and radiation. Okay, so here they are. We want to talk about convection first because it's the most important. So I'm going to start by making a few notes and I'll get you to copy them down. Okay, so convection is, when we're thinking about the atmosphere, this is our primary mechanism for heat transfer in the atmosphere. And really, it's all about free-moving molecules. So molecules and particles are free to move around in the atmosphere, just as they are free to move around in the hydrosphere and the geosphere as well. So this method of heat transfer is really important in those as well. And we think about the geosphere, and we think about plate tectonic movement and the method of movement of plates within the movement of magma within the mantle or the asthenosphere. And then we also think about movement of water in the hydrosphere as well. Convection is our primary mechanism. But without convection in the atmosphere, there would be very little heat transfer or movement. So convection is really important. The big deal about convection is it changes the density of the material that it's in. So I'll demonstrate this by, I guess I'm going to draw our famous pot. And I'm going to put a fire under this. I'm going to fill it with water. So if we think about what happens at point A, point B, and point C, and you guys will be familiar with this. I've drawn this many times before. So at point A, the water is heated, and it's at this point there the water becomes less dense. The spaces in between the molecules become further apart, and our density lowers. So because our density is lower than the surrounding water, the water is going to rise up. When it gets to the top, obviously it can't keep on moving through, although there will be steam formed. But actually what will happen is our water will move across where it will start to cool. Because at point C, it is our furthest point away from our heat source. So the water is going to be coolest at this point. Now then when it's coolest, the particles and molecules are going to be close together and that material is going to be more dense. So what's it going to do? It's going to sink. And we end up with this nice little flow where the water makes its way back down to the bottom of the saucepan, and it's a handle. And we have our convection current. So to put it simply and make sure you understand, heat changes the water density, the water becomes less dense than the surrounding material and then rises up. And conversely, the denser material falls. This happens all the time, every single day in the atmosphere. It is our primary mechanism for movement. Let's look at radiation. Radiation time. So radiation is really important because this is our heat budget essentially. Where conduction and convection need to travel through some object in order to move, radiation simply just makes its way from the object that's emitting the most heat. So it can travel through anything, even the vacuum of space. Now, there's 4 points about radiation, and I'm going to write them down one by one. Fact number 1, all objects above 0 Kelvin emit radiant energy. And for the first person who can comment and tell me what 0 Kelvin is in degrees Celsius, I will make sure a chocolate comes your way. So the first one is every object above 0 Kelvin will emit radiant energy. Number 2, hotter objects emit more energy than cold objects. Well, that's pretty obvious, isn't it? Next, hotter objects, or objects with more energy, will emit waves of a shorter wavelength. Now we see this, and we've talked about this in the heat budget. The sun, obviously it's a much hotter object and a object with much bigger mass. It emits shorter wavelengths, whereas the earth, well, it emits longer wavelengths. And the last one, objects that are good absorbers of energy are also good emitters. Cool. Now, our last movement of heat comes down to conduction. Let's write some details about this. All right, conduction. Well, here's some facts about conduction, and this is probably our least important atmospheric heat movement. It is kinetic energy. If you think back to year 8 science, it's when kinetic energy moves the molecules, they vibrate around, and heat moves from areas of high heat or high energy to low energy. Obviously, they do that until they meet and there's thermal equilibrium. And look, heat conduction will vary depending on the object. Metal, as you know, is a really great conductor of heat. Air is a very, very poor conductor of heat. And that's all we have to say about that. So next one is we're going to look at the greenhouse effect.